Slant Asymptotes. You always have slant asymptotes when you have a degree on the numerator that is bigger than the degree on the denominator. You see the highest exponent on the top is 2. The highest exponent on the bottom is 1. So the degree on the top is bigger than the degree on the bottom. That means we do not have horizontal asymptotes. But before we get to horizontal asymptotes, let's go ahead and find our intercepts, because that would be the first thing you want to do. That's the easiest thing to do, I suppose, at the very beginning. So let's find our y-intercept. To find our y-intercept, we got to plug 0 into all the x's. So we get 0 raised to the second power minus 0 minus 2. And on the bottom, we have 0 minus 1, which equals negative 2 over 1, which equals positive 2. So here's our y-intercept right there. And now to find our x-intercept, we're going to have to set the numerator equal to 0. The reason why we set the numerator equal to 0 is because it doesn't matter about the denominator, because if 0 equals x squared minus x minus 2, and the denominator is x minus 1, you multiply both sides by x minus 1, and it cancels out, and anything times 0 stays 0. So now we have this equals 0. To solve this, we're going to factor and use our 0 property. We have x minus 2 times x plus 1. This equals 0. X equals 2 and negative 1. What? There's 2 x-intercepts? Yeah, there is. All right, now the next step was the asymptotes. No, it's not 2 s's. It's just 1. Always 1. Asymp. Okay, now we have first our vertical asymptote. To find our vertical asymptote, we just take the denominator and set it equal to 0, and you don't even have to do that. You can see it pretty clearly that x cannot equal 1, so x equals 1 is our vertical asymptote. Now, what about our horizontal asymptote? None! Because the degree on the top is bigger than the degree on the bottom. So what do you do now? Now, you might have thought this. You might have thought, well, I'm just going to factor this top thing right here and factor the bottom thing. Oh, bottom thing's already factored. And then I'm going to start canceling stuff out. Well, if you can start canceling stuff out, this is actually not going to be a rational function when you graph it. This is going to be a straight line, because think about it. These were able to be canceled out. You have x minus 2. If you graph that, that's just a linear equation, right? Yes. You should not be able to simplify it like that. So what you're going to do now is you're going to divide. Now we can divide using log division, synthetic division, or the reverse tabular method. What do you guys prefer? Synthetic, yes. If the denominator is just a binomial, you can use synthetic. If it's something else, you can't use synthetic. All right, but we can use synthetic, so I'm going to put a 1 right here because that is the 0 for the denominator. And then I'm going to put 1, negative 1, and negative 2 on the top. It's weird. We're doing synthetic division with a trinomial. We only have 3 numbers here. The first one we drop, we get 1. The next one, we go 1 times 1, which is 1, and then I get a 0. And 0 times 1, which is 1, we get a remainder of 1. So,
0 times 1 is 0. Yeah.
Oh, thank you. 0, yeah. I know how to multiply. Okay, so I get negative 2 for my remainder. Negative 2 is your remainder. Negative 2 over x minus 1. And then you have a 0, and you have a 1x. I don't need to write that 0. I just wrote it because, I don't know, you guys might skip the constant. Okay, now, when you're doing your slant asymptote is everything except the remainder. You just cut it out. Slant asymptote is y equals x plus 0, but we don't need that plus 0. Just y equals x. Yeah, so your slope is 1. Your y-intercept is 0. This is an asymptote. Okay, so let's see what this looks like. Okay, let's do our intercepts first. We have a y-intercept of 2, so I'm going to put a dot right there at 2. We have 2 x-intercepts. We have 1 x-intercept at 2. Negative 1. Sorry, negative 1 right there. And we have another x-intercept at 2. Put a dot right there. We have a vertical asymptote at 1. So I'm going to put a dotted line like so. All right, now we have our slant asymptote. What is our slant asymptote? It's a linear equation. There it is right there. Y equals x. So we just go like this. You cross the 0. Y-intercept is 0. And then because we already have points, we just have to connect our points. Remember, the curves are attracted to asymptotes. So when you draw your line, you need to go towards the asymptote. And that's it.